I am here, and I'm here to give you a presentation on whose threat model is it anyway. I gotta hit the on button. There we go. Technical difficulties, there we go. Hey, the presentation where the scenarios are made up and the controls don't matter. Now, I'm hoping by the end of the talk, I will give you feeling less like Colin and more like Ryan, or at least like Wayne there. An alternative title for this talk was Travis has read a book on threat modeling and now he has opinions. Unfortunately, we came up with an even better title for this talk too late. We really like, if you're not threat modeling, you're regret modeling. So keep that one in mind. So this talk has a special guest appearance by my garage door. I hope you all look forward to getting to know my garage door more thoroughly later. So a little bit about me. I am, as I mentioned, Travis Friesen. I am currently a senior infrastructure developer at Neo Financial, and I do a generous helping of cloud security as well. We're doing some interesting stuff there. Come talk to me, come talk to that guy, come talk to that guy, come talk to Marcello. Where'd you go? That guy in the back there. We're having some fun if you want to talk about what we're doing. We're always interested for talk. So yeah, this is what I do, or in other words, I do computers. You know, like literally everybody else in the room, or some of us do networking, I guess, instead. So yeah, just like everybody else. So this year, it's going to do something a little bit different and maybe give you an insight to a little bit about me. And I like to cook. I think cooking is, in fact, the best hobby you can have, right? Because you got to eat anyway, right? You got to spend the time and the money. Yeah, you got to spend the time and the money prepping the food. You may as well enjoy it. Plus, it's the sort of hobby that just about everybody can enjoy along with you, right? Nobody gives a shit about your Pokemons or your hockey cards, right? But everybody's sorry, but everybody loves a second helping of your beer braised short ribs or something like that. In fact, it's one of the few hobbies that can actually save you money compared to eating out. But I mean, realistically, you just end up spending that money on new cooking gear. But it's the thought that counts. I just turned 40. The rumors are true. Yeah, it's all the cliches aside, getting older is actually kind of awesome. Because the older you get, I find, the less of a shit you give what other people think. It's fabulous. Yeah, I got a lot of nods in the audience on that one. The whole body slowly shutting down on you thing, not as good, but you got to take the good with the bad. I recently found out I probably have ADD. That's the sort of thing that it came as a bit of a surprise, but also explained so many things, But then I probably don't need to talk to this audience about neurodivergence. I'm in good company in that one. So anyway, enough of that kumbaya bullshit. What is threat modeling? What is a threat model? So you might be under the impression, might be forgiven for thinking that threat modeling is the act of creating a threat model. But no, in fact, you actually kind of have the relationship backwards. Rather, the threat model is what you use to do threat modeling. Right? The threat model is the inputs, the framework within which you do the threat modeling. Right? It's what informs the activity, if you will. So you can kind of think of it like the initial parameters for a model of the solar system, right? It's where you put all the planets and their sizes and what they're doing, from which you can then do your calculations and your science or whatever on the resulting system. So, but what is a threat modeling? It's brainstorming at the end of the day. It's fancy, glorified brainstorming. Ideally, it's focused and structured, but at the end of the day, you're still basically just trying to brainstorm. You're trying to brainstorm potential threats against your system. You're sitting down with a group of people, stakeholders, and saying, hey, how can we improve the security of the system by trying to determine ways of attacking it? What are the threats that are posed to it? Why should you do threat modeling? Well, as I've kind of hinted, the goal of threat modeling is to make your system more secure. It's to find potential vulnerabilities and bugs, ideally as early in the development cycle as possible, right? It's always easier to find and fix a security bug when you're still designing the system than 6 months down the road when you have to hand it off to the pen testing team and pay them a bunch of money to find something that you could have fixed way, way earlier. So that's what threat modeling is. The threat model itself, though, is the high-level description or diagram, the model, if you will, of the system that we're trying to secure. But it also consists of the threat actors and the motivations that might act against your threat model, rather your system, pardon me. It's also think of the potential goals, resources, the crown jewels, we've heard that term a lot this weekend so far, that a threat actor might be interested in. It's the money, it's the data, it's potentially the CPU or the network time that your system uses. And so here's an example threat model, like a system diagram that you might use for threat modeling that I ripped off the internet. At first glance, it might seem pretty complicated, but when you kind of look at it, you realize, it all kind of makes sense. It's pretty basic, right? You got a browser talking to a web app, got a config and a database and all that sort of thing, right? Pretty straightforward. But what you'll notice is that while it specifies, say, a database, it doesn't specify what kind of database. We're not interested if it's a MySQL or a Dynamo database, right? We're not interested in what kind of servers these systems are necessarily running on, because in theory, you should be able to change those out without meaningfully changing what your threat model is, right? It's kind of a higher level abstraction than that. So the importance of having a good threat model is it allows you to focus on the relevant threats to your system, right? Sometimes what's in your threat model isn't even as important as what isn't in your threat model, because all controls have a cost, whether that cost comes in the form of development time or license fees, or you need to use more resources to run your app, whatever, right? There's no free lunches when you're implementing security controls, so you want to make sure that you're choosing security controls that actually matter for your system. So on the topic of figuring out what kind of threat actors that you're worried about with your system, I kind of like to group them in a handful of categories, and I've kind of ordered these in kind of like a decreasing order of sophistication, if you will, or decreasing order of how fucked you are, let's be honest. And right at the top, you have your government agencies, your NSAs, your CIAs, and all those sorts of guys. And down from them, you have your big-time criminals, is how I like to describe them. These are, the sort of hacking groups that they're looking for multi-million-dollar payouts on any given hack. These are the guys who hacked the SWIFT system for $100 million, right? And these are the sorts of guys who will gladly sit on your network for 6 months until your backups expire before finally springing their trap, right? Down from them, you got kind of hacktivists, like Anonymous, for example, potentially competitors, if that's a concern for you. And then down from them, you have like your small-time criminals, is what I call them. The people who are looking to operate in volume. They want to do 1,000 hacks at $200 each instead of one big hack of several $1 million, right? And lastly, of course, you got the old script kiddies and students, people trying to just play around with it and mess shit up. So as I mentioned, what's not in your threat model can be extremely important. And realistically, for most people, the NSA is not in your threat model, right? The reality is most of us just aren't that interesting. Sorry. So unless your name is Ron Bowes or something, you're probably not interested. You probably don't have to worry about the NSA. Similarly, your cloud provider. Your cloud provider is usually not in your threat model, right? Because the reality is if AWS decides to go rogue someday, they're probably not coming after you. They're not going to waste that on your handful of S3 buckets or whatever it is you have. Okay, so to kind of help to illustrate the importance of a good threat model, I'm going to give you a case study. And as I promised, this will involve my garage door. But first, a little bit about lockpicking. So I know there's probably some people here who have experimented with lockpicking and locksport and that sort of thing. And when you first get into the hobby, and you go online and you read the forums, you probably eventually encounter somebody saying, after I first learned to start doing lockpicking, my eyes were opened. I immediately went out and I got fancy new locks for my front door. I upgraded the locks so they can't be picked so easily anymore, right? Or maybe you've heard the aphorism that locks are for keeping honest people out. Now, it is my opinion, and I think I'm going to demonstrate that I think both of these sentiments demonstrate a failure of threat modeling. Bear with me. Here's my garage door, as promised. So I live in not the best part of town. It's not particularly unsafe, I say as a 6'2" male, but it is the sort of neighborhood where if you don't keep your stuff locked up, it tends to disappear on you if you're not careful. So shortly after I moved in, I had a couple of incidents where somebody made it into my garage and made off with a few of my possessions. And so I made some upgrades to, among other things, the side door to my garage. And this is what it looks like today. So anybody out there do any physical security stuff? Can anybody tell me what's wrong with this picture? Hinges. Excellent. You fell directly into my trap. You're absolutely right. Yeah, the hinges are on the outside of the door, and somebody could come along and pop the hinges off and get the door out that way. There are things you can do, and things I have done, compensating controls, if you will. You can't get my door open that way. There's other stuff going on I'm not going to tell you about that prevents you from opening the door that way. It's a poor magician who explains all of his tricks and tells you how to break into his garage. So, so I'm not going to tell you that one. You can probably guess if you know. The other thing I was hoping you might mention is the padlock that controls the door. Now it is, if you look closely there, it is in fact a master lock. It's got a pretty substantial shackle on it, and it's got a security hasp there. But the keyway is super exposed, and being a master lock, it's not particularly hard to pick. Yet, despite the fact that this is absolutely eminently pickable, since upgrading to this 7 or 8 years ago, I haven't had any issues of somebody, picking my lock and getting into my garage that way. And I'm not particularly concerned about them ever doing so. And the reason for that is ultimately that criminals are kind of both dumb and lazy at the end of the day. They're not very smart. And that's kind of true by definition. Like if you're the sort of person who's willing to, risk your liberty for the couple $100s you could get fencing the goods in my garage, you're probably not very bright. Or at the very least, you're kind of short-sighted. And the thing is, learning lockpicking, by comparison, is a skill that takes time and patience and effort and dedication, right? Anybody can learn it, but it still takes kind of applied practice to do so. It's the sort of thing that most petty criminals are probably not going to invest in. Now, I add an asterisk to that because I have heard, incidentally, that in Europe, sometimes you'll find that petty criminals know how to pick locks, but for whatever reason in North America, they just can't be bothered. So, now it's not a Travis Friesen presentation without a crappy MS Paint Venn diagram, and so you can see here the sets of people willing to learn pick locks and people who are interested in my garage is pretty much a disjoint set. If there is any overlap, it's basically just Mike Himbo in the middle there, but I know where he lives, so it's not too much of a concern. So to state it more formally, people who are not in my threat model are people who know how to pick locks. But in my threat model is people with bolt cutters, which is why instead of spending $200 on a fancy unpickable lock, I spent $30 on a master lock with a hardened shackle and a security hasp, right? I end up in a situation where I am more secure for less money because I applied good threat modeling to the system of my garage door or whatever. Okay, great, threat modeling, it's important, you should do it. How do you do it? Great question. Step one, build your threat model, right? That's where you're going to start from. Those are your initial parameters. Make sure you've established what a good threat model is, what your threat model is, right? Describe your system and the components involved at a high level. Determine what the threat actors and their motivations are. What are they coming for? Are they coming for your money or for your data? What in your system might a threat actor want to exploit for their own gain? Step 2, do the threat modeling, which I realize not particularly helpful. But the reality is it's brainstorming, right? And how you actually run such a session is going to depend a lot on you, your organization, the system you're trying to do the threat modeling on, what skills you have, what experience you have, right? There's no really one size fits all for when it comes to sitting down and getting the team together and doing the threat modeling for your system. I do have a couple of tips that I can pass on that can help you, threat model effectively. And one of the most common tips you might hear is try to think like an attacker. Now, at a glance, this seems like a great idea, right? Try to get into the mindset of the attacker, right? How could they exploit my system? Could they do SQL injection or cross-site scripting or whatever to try to exploit it and get at the, whatever it is we're trying to protect? This is great in theory, but the problem is most of us aren't threat actors at the end of the day. Most of us don't even have, the offensive security background. So it can often be very, very difficult to try to kind of get into that mentality if you don't have that experience. Another technique you can use is called the stride technique. This is basically a very rough category of different kinds of attacks that you might see a threat actor use to get at your system. And it's kind of categorized into spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So you can kind of work your way through these categories to kind of give you some potential ideas of potential threats your system might face. So some examples of spoofing. your classic, spoofing an IP address or spoofing an account. Tampering can include things like replaying messages or modifying cookies or request URLs. And information disclosure can be things like if you have error messages in your application, are they disclosing too much information, right? There's a fine balance between providing enough information in an error message to be useful for debugging and not providing so much information that it becomes useful for an attacker. So similarly to Stride, you have the OWASP top 10 if you have a web app. It's a good category of different attacks. And the MITRE attack framework has been probably mentioned a couple of times today. A really good exhaustive list of techniques, tactics that threat actors could use to attack your system. So these are also really good sources of potential threats and ideas that you can use to help you threat model. Another one is called attack trees. These are kind of fun. You start by putting what the ultimate goal is at the top. That's your root node. So the goal here is that someone wants to steal money from a bank account. And then going kind of a level down, you kind of list all the ways that someone could potentially, what's kind of their ultimate step before getting to that. In this case is, well, I could get the money from an ATM or I could hack their online bank account. And then for each of these nodes, you go and create yet another level. And how could they possibly do that? Well, they could shoulder surf the PIN and they could steal the credit card, for example. For hacking the online bank account, maybe they phish them or steal the password, right? And you can kind of iteratively go down the attack tree like this and come up with all potential threat vectors that someone might use to help you secure your system. And lastly, step 3 is actually fix the bugs that you find in the system, right? All the threat modeling in the world isn't going to help you if it doesn't result in patches and actual code to improve the security, right? There's a lot of situations where follow through isn't always there. So that actually ran quite a bit faster than I expected. So that is all I got for the day, and enjoy the rest of your evening if you don't have any questions.